So now that you implemented your first version of Dijkstra's algorithm, let's make our first improvement. And this will be just a cosmetic improvement and not an improvement of the algorithm as such. So let me show you the outcome. So if in this improved version I set the start and the goal, it will do routing exactly as before. However, it will represent the actual distances using different intensities of green. So zero cost is at the start node, and the maximum cost is when it reaches the goal node. And if I place this somewhere else, then it will expand accordingly. And as you see, there's now larger distances, but the green intensity automatically rescales so that the maximum distance is always represented by a green color with maximum intensity. Now, if you're adventurous, you might try out defining a maze, for example, by drawing with the left mouse button those obstacles, and then you can see nicely how the algorithm explores from the inside to the goal, and using the middle or right mouse button can of course punch some holes into your maze, and so you will get different results. So now let's modify our previous algorithm to get this nice visualization. And the required modifications are quite minimal. So remember when we discussed how the algorithm proceeds on a graph, where we did two things when a node was visited. First, we crossed out the node, and the second thing was, by the very moment we marked this node as visited, we also fixed its cost of 4.4 or whatsoever. Now in our case, we have this raster, an array called visited, where we started from our start node. All the array cells were initialized with 0, and as soon as we visited one node, we replace that value by a 1. So as the algorithm proceeds, it will replace all those zeros by ones. We now also want to record its cost. So we would need a second array where the cost of the start node is 0. And so whenever we mark a node as visited, we write down the cost of this node in this second array. Now here comes a trick. Instead of using a second cost array, we will just use a single array where we will record the cost, and whenever the cost is larger than 0, we know we have visited this node. So we will just keep our old visited array, and instead of marking this with zeros and ones, we will mark them with the actual cost. So this new array of visited values will contain all zeros in the beginning, just as we did earlier for our visited array. And then whenever we visit a node, we will replace this 0 by the actual cost. So we have one little problem here. So remember that our start node actually had the cost 0. If we visit this node, we will put in this value, this cost value of 0 into our visited array, meaning it will look as if the start node was not visited yet. So we make a little trick here. We set this value actually to a very small number. So when the start node is visited, this small number is put in here, which is then larger than 0. And by using this trick, we can use a single visited array to record all the visited nodes and at the same time record all the cost values. So let's have a look at the code you'll have to implement. And the changes are really minimal. So the code now is PPO1B, and let's have a look at the main part. Now in general, we started with one version of the Dijkstra algorithm, and we will modify this constantly, but I won't show you the solution. So what you'll need to do is you'll need to start with your previous implementation and copy all the things you did in the previous implementation to this new version, where the comments here stay the same, so it is easy to identify the places where you have to put in your previous solution. Now first of all, you have to modify this cost. Instead of 0.0, use a small number. It must be positive, and it should be substantially smaller than 1, the unit distance, so that it won't have an effect on the algorithm itself. And the only second change you'll have to do is, instead of marking the visited node with 1, put in the actual cost of the node, which is just the variable cost that has been determined from the element we picked from the front. So this is the only two changes you'll have to do. And after that, you should be able to see the distances visualized as different intensities of the green color.